I am Ajinkya Patil from DYPATIL College of Engineering Technology. I am representing team Torque Engine under guidance of A.J. Raiker sir. Here it is the conceptual design of our car. Now let's start with the vehicle specification. Dimension: overall length 65 inches, overall width 53 inches, wheelbase 42 inches, front track width 38 inches, rear track width 40 inches, ground clearance 1.5 inches. We kept the ground clearance 1.5 considering the factor of safety. Now the performance, maximum speed we kept, that is 72 km per hour considering the other competitions. Minimum turning radius 3 meter. Engine, we searched the various engines like Discover, Stunner, Shine. From that we selected the Stunner engine because it is more reliable and also smoother than other engines. Also, as our personal experience that we are using bike from last 3 to 4 years, we having that engine having low maintenance and more durable. So we use the engine of Honda Stunner 125cc, displacement 124.55cc and maximum output 11 bhp at 8000 rpm and maximum torque 11 Newton meter at 6500 rpm. Transmission, we are using manual transmission. Gearbox of Honda Stunner 125cc. Steering system, we are using the tie rod and pit arm linkage mechanism. Brake, we are using hydraulic disc brake as per the rule book. Tires, we are using the tires for front and rear tubeless tires. Now, design of go-kart. We done the design of go-kart in Creo 3.0 software. Here are the some views of our kart. Now, the material selection for the chassis. Selecting suitable material for the chassis, we search the various materials. From that we choose SS304 material that is having high cost, so we have not considered that material. Moving further, we after searching the other materials from our seniors, we get to know that AISI 1018 material is best for the chassis. So we use the AISI 1018 material. Its specification is given, and having this material having high machinability and power and having high rigidity. Moving further, we'll go to the design methodology. We first selected the driver and engine. Considering these two, we roughly designed the chassis on the card sheet. As per rule book, final dimensions are given. After that, we done the model, the proper chassis design is done in the CAD, and finally the whole assembly is done. After that, finite element analysis. We done the analysis on ANSYS. Various stresses and forces are calculated on the software. Here, the force act up to 5G. The force is acting up to 5G. After that, applying this force, we get the result. This design is permissible limit. After acting this force, we get the design at the permissible limit for the front, rear and side impact. After that, we done the model analysis which are shown here. The result we got, that is, in case of front impact, the factor of safety we got is 1.2. For the rear impact, we got the factor of safety, that is 2.02. And for side impact, we got the factor of safety, that is 2 to 3. Now, ergonomics and safety of the driver and as well as car. Ergonomics, sufficient cockpit area we have given, sufficient legroom, as also we give the comfortable position to the driver, as well as we provided a firewall to the driver. For the driver, aerodynamic shape also given, window vision code. Considering the safety, we give the electronic skill switches for the driver at the front as well as the rear side. We also give the foam padding and on the roll cage members. Also give the fire extinguisher within the reach of the driver. We provide the kill switches and give the gears to the driver. Now the further part will be described by my colleague Saurabh Wadkar.
While designing steering system, as per the criteria, it is required to have shortest turning radius of kart, so that we have choose the tie rod and it is effective tie rod and pitman arm, and it is effective to choose it is effective turning and less steering effort than the rag and pinion. we have kept the maximum inner wheel angle 19 degree, maximum in the outer wheel angle 20 degree. We have using Ackerman's steering mechanism geometry, so that we get the turning radius of 3 meters. We have kept the camber angle 0 degree, so that our weight of our cart is very less, up to 160 kg. We have kept the caster angle 7 degree, kingpin inclination 7 degree, and toe in front wheel 0 degree, so that we have toe in front wheel 0 degree, so tire wear reduces. Further, we move to the braking system. We have kept the front weight 45% and rear weight 55%. We have calculated the front weight 72 kg, rear weight 88 kg. We have kept the ground clearance 1.5. Then we have calculated the dynamic force 77 and dynamic rear weight 99 kg. We have kept the pedal ratio 6:1. As the driver give the 100 Newton force to the pedal, it converted to 600 Newton. We have used the Tata Nano master cylinder, which have piston diameter 19.4. Brake. Then we have used the brake disc 150 mm. As we know, the braking torque required to stop the vehicle is more than the driving torque. So we have calculated the braking torque 11.5 Newton meter, and then we have calculated the stopping distance 5 meter for the 40 kilometers per hour speed of our car. The next information will be given by my friend Akshay.
Here my role is to describe the powertrain, in which we have used the Honda Stunner 125cc gearbox. For operating the gears, we have used the manual transmission. This gearbox containing the 5 gears. We use the chain drive to transmit the power from engine to the rear axle. Here we have studied the two chains, which are 12A and 12B, in which we have selected 12B because of its more roller diameter, which gives more strength. Then there are a number of linkage, approximately 69, which we have used. Then there are 2 sprockets which I have used. The first sprocket having the 14 numbers of teeth, and second sprocket having 41 numbers of teeth. The sprocket reduction ratio is 2.92. The sprockets are mounted onto the shaft with the help of hub and flange. Then the diameter of the shaft which we have used is 35 mm, which is made up of EN8 material from EN8 material. In Indian standard, it is C45, and the ultimate tensile strength of that material is 660 Newton per mm square. Then we have used the pedestal bearing to support the shaft, and it is locked with the help of collars besides bearings. We have mounted the engine vertically with the anti-vibrating material to reduce the vibration produced. By using the powertrain, we have to achieve the speed of 72 km per hour and torque 11 Newton per meter, which is below the target we have done. And front and rear tires are used as per the standard. Then the further information will be given by my colleague Prithviraj Patil.
Let us discuss about the manufacturing and cost summary. First, we will discuss about the manufacturing. The facilities which we have given are first in-house facilities which we have got in our college, the library, the CAD/CAM lab, and the manufacturing facilities such as we have 2 machine shops, one machine shop as well as welding shop. In machine shop we have drilling, grinding, hacksaw, circular saw, HMC, and as well as CNC machine. There is also a famous area in our city called Udyamnagar, where we can do other machinierings. Now let's move to the cost. We have divided the cost as per the percentage using a pie chart. Now we will discuss about the department division. There are 16 members in our team. The departments such as braking system, engine department, design department, transmission department, electrical department, braking department, and so on. According to the keen interest of our students, we have divided the students according to department, and considering the examination as well as the college schedule, we have divided our work as per the months. and the further information will be given by my colleague Pratik Patel.
Design validation plan. After completing our design process, we need to make sure safe working of our design under different conditions before actual implementation. So we carried out various tests on our design. So we used both physical and virtual testing method. Physically we tested the chassis pipe strength and rail quality on the universal testing machine. We used the ANSYS software for impact testing, and we also determined various parameters such as turning radius, braking distance, etc. The results of this test proved our design safe for implementation. Moving on further to the design failure mode and effect analysis. In this analysis, we divided our vehicle into 4 main subsystems, which is engine, transmission, steering and braking. And we listed the potential failure modes and their corresponding effects. As the failure of braking will be more severe than any other system in the vehicle, we have rated the high severity number for the braking system. As the occurrence of failure in engine, transmission and braking will be same, as we have used readily manufactured parts and installed in our vehicles for engine, transmission and braking, their occurrence of failure will be same. So we have rated the same occurrence number for these 3 systems. Now the detection of failure in engine, transmission and braking will be easy, as it will directly affect the working of our vehicle. And in case of steering, we can detect the failure only when we use the steering. So comparatively less number for detection. Then we have calculated the risk priority number by simple multiplication of 3 factors: severity number, occurrence number and detection number. Our main aim in this analysis is to reduce the risk priority number. So we have found out various alternatives and implemented the optimum alternatives for reduction of RPM, risk priority number. Here we can see the RPM number is reduced greatly from 270 to 175, as we can see in the slide. Respected sir, I am feeling very proud to tell you that our team top rangers have directed all our efforts and all the engineering knowledge we know in creating such a vehicle which is best and optimum in our views. We believe that our vehicle will clear all the tests conducted by the NKRC and will qualify for the NKRC championship and is capable of winning the championship.